NASA's James Webb Space Telescope is not only observing the far reaches of the universe and celestial bodies, it is also providing unprecedented insights right here in our own backyard, the solar system. Using Webb's infrared images, astronomers have, for the first time, confirmed the presence of water vapor around a comet in the main asteroid belt, indicating that primordial solar system water ice may be preserved in this region between the orbits of Mars and Jupiter. However, this water presence has brought about a new mystery. Unlike other comets, Comet 238P/Reid shows no signs of carbon dioxide, CO2. It was named RED in honor of its discoverer, Michael T. Reid. Our water-soaked world, teeming with life and unique in the universe as far as we know, is a mystery. We're not sure how all this water got here, said Stephanie Millam of NASA's Goddard Space Flight Center. Understanding the history of water distribution in the solar system will help us understand other planetary systems and whether they may be on their way to hosting an Earth-like planet. Comet RED is a comet that resides in the main asteroid belt but periodically exhibits a halo, or coma, and a tail, like a typical comet. Comets within the main belt themselves are a relatively new classification, and Comet RED was one of the original 3 comets used to establish this new category. Before that, astronomers believed comets resided only in the Kuiper belt and the Oort cloud, beyond Neptune's orbit, where their ices could be preserved due to their distance from the Sun. Astronomers have long speculated that water ice could be preserved in the asteroid belt, but there was no definitive proof until now. The frozen material that vaporizes as comets approach the Sun is what gives them their coma and tail, setting them apart from asteroids. In the past, we've seen objects in the main belt with all the characteristics of comets, but only with these precise spectral data from Webb can we say definitively that yes, it is definitely frozen water creating this effect, said Michael Kelly of the University of Maryland. With Webb's observations of Comet RED, we can now demonstrate that early solar system water ice can be preserved in the asteroid belt. Indeed, the absence of carbon dioxide in the celestial body was a greater surprise than the presence of water. Typically, CO2 makes up about 10% of the volatile material in a comet. The research team proposes 2 hypotheses to explain this absence. The first hypothesis suggests that Comet RED may have had carbon dioxide and it formed but lost the gas due to the higher temperatures in the asteroid belt. CO2 ice vaporizes more easily than water ice, and the warmer conditions in the asteroid belt could have caused its depletion. The second hypothesis suggests that Comet RED might have formed in a particularly hot region of the solar system where carbon dioxide was not available. These hypotheses can only be confirmed or ruled out by studying other similar bodies or visiting these comets. Now that Webb has confirmed that preserved water can be found as close as the asteroid belt, it would be fascinating to follow up this discovery with a sample return mission and learn what else main belt comets can tell us, suggests Stephanie Millam. Further exploration and research will be crucial in unraveling the mysteries surrounding comets and their compositions, shedding light on the origins and evolution of our solar system.